Hello, my friends. Welcome back to yet another lesson in the Vibite algorithms and Olympiad track. I call this Binary Trees and Heaps. And as the name suggests, in this lesson, we are going to take a deep dive into the world of trees as it comes in computation, computer science. And we are going to look at this very beautiful, very important, very, let's say, useful data structure called heaps, which is, basically a binary tree that works on lists. So we're going to see this in a lot of detail in this chapter. Try to understand what heaps are, why they are useful, and so on. And in the subsequent lesson, we are going to see how we can apply heaps to solve some really really interesting problems. So let's just do a little bit of recap. We have been working with lists all along. For example, we built data. We looked at problems where data was stored in lists, say altitude of an aeroplane, items to be shipped, numbers for the Pearson problem, and so on. And obviously, in this time, we have also looked at several algorithms that work on lists. For example, searching values in a list, sliding windows, two-pointer problems, and so on. We have looked at sorting. Now, lists are really powerful because, the important point is lists allow what is called random access, which means that, for example, if I want to go to item 10, I don't have to go from item 0, 1, 2, 3, 4. I can directly go to item 10, and which is why it's great for searching and, all the other things that we have seen about lists. However, everything that we have looked at so far is sort of static in nature. So what we mean by that is that, we have a list of values and we operate on them, but we did not bother about things like, new items entering this list, or possibly some items getting removed from the list, or let's say the values of these items changing with time. So whatever algorithms we worked on, whether it's search, whether it's two-pointer problem, always assumed that the list is available and that stays static. However, in many real world problems, in fact, the situation is quite dynamic. Things change. Let's take some examples. Let's say you're running a bakery. Now, in a bakery, obviously, new things are being made all the time from the kitchen, from the oven, and old items are getting sold. You may want to know what items have the shortest shelf life at any given point of time. So, for example, cream, depending on the weather, will spoil quite fast. So, you may want to know, okay, this I've got these items which use, say, a kind of cream. I may want to sell that the fastest. Similarly, let's say you're managing a hospital emergency room. New patients keep coming in, and there's an initial check done, and basis that they are given a priority rating. Let's say a lower number for higher risk cases, which is what is usually done. Now, you want to find out that you always want to find out the person who has got the highest priority, which is the lowest number, and treat that patient. Now, again, notice this is a dynamic situation. There are patients, and then suddenly a new patient comes in, perhaps with a much more higher priority. Then obviously the treatment must be given to that patient. Similarly, let's say you're in school carnival, you want to see, okay, students are coming, going out. You may want to track who is the youngest student of all. What is the student's age? What is the youngest student's age in this carnival at any given point of time? So once again, imagine that, look, this situation is dynamic. We don't have a fixed list of numbers. This list of numbers is evolving as the time goes, and we got to find, let's say, the minimum or maximum at any given point of time. In fact, many, many, many such situations arise. Let's take two more examples. Imagine maintaining a task list. Now, all of us are quite packed these days. We have busy schedules. We have new tasks coming up all the time. The priorities of these tasks keep changing. At all points, we would want to be able to attend to the highest priority task. So, whatever is highest, we attend to that, and then we move to the next one, and so on. So, again, this is a dynamic situation. Some tasks might become, let's say, no longer needed. So, tasks can get out, get in, but at all points, we want to keep us aware of the highest priority so that we can attend to it. One more example is a live leaderboard. So imagine running an online game, for example, like a Kahoot quiz, which we play quite often. Let's say players are playing, and the scores keep changing. We want to dynamically keep track of the top few winners. Once again, keep in mind that this will change, because depending on how players are scoring, and we want to, let's say, list the top few. So that the point I'm trying to make is that these are all situations where there's a, let's say, dynamic nature to this. So things keep changing. There is a need to track the minimum or the maximum of this, let's say, changing data. At the same time, not lose the other items in the list. Now, this is very clear from, let's say, the task list example. We want to do the highest priority tasks, but at the same time, we don't want to drop the other tasks which we have not done. Similarly, very vivid also from the hospital ER room case, where new patient comes in. All right, the patient, if the priority is high, will be given treatment, but then the previous patients also need to be given treatment. So we got to keep track of everybody, but find out the minimum or the maximum. And now these problems are also called priority queues because we're basically assigning a priority to every item and we want to find the maximum priority at any given point. There are many, many such examples. Um, it turns out that once we have a dynamic situation of this sort, lists are useful. So we will use lists. However, lists alone do not cut, right? So basically what we are saying is that viewing data as a static list alone, the way we have been doing is not sufficient. It turns out that imposing a tree structure on these lists greatly improves the efficiency. So that's the direction we are going in. We are going to talk about trees in this class. We're going to see what trees are, how do we impose them on lists, and specifically we are going to look at a tree which is basically a binary tree, a complete binary tree. We'll define all of these things going forward. These trees will help us to track the minimum or the maximum in a dynamic environment without losing information on other items. And the name of these trees is heaps. So basically, heaps is this very powerful data structure, which is a tree, which allows us to solve these priority queue problems in a very efficient manner. So that's the main focus of this, let's say, lesson. In this lesson, we'll start from the basics. We'll look at trees. We will quickly move on to what heaps are. Now, there's a lot of literature, a lot of terminology, but we'll focus on what we need to learn, and let's say cut through the all the terminology to get to the structure of heaps, the important points about heaps. Like I said, very useful, very interesting as well. We'll see why heaps are, so special. We'll learn about the key operations related to heaps, and we'll also understand why static lists alone do not match the efficiency that we get with bringing heaps into the picture. We'll in fact quantify this. So with this, the learning objectives are, well, understanding trees in general, understanding why it helps to impose this tree structure, how do we do it, understanding heaps, which is a special type of binary tree, how heaps are represented and indexed within a list, converting a list of values to a heap, basic heap operations, insertion, deletion of nodes, and so on. And how does heap help us? How do heaps help us to solve priority queue problems efficiently? And why lists alone won't work? Like I said, we are going to quantify this. Now, once in this chapter we are through with the basics of heap operations, basics of heaps, in the next lesson we are going to look at several problems where we'll apply heaps to solve very, very interesting scenarios. Obviously, as always, we'll do this in a step-by-step logical manner so that the learning is systematic as well as fun. At YByte, our approach is always to cut through the jargon, focus on the concept, and learn in a systematic manner. Look at our website www.ybyte.in for many, many, many fun programming activities. Take care. Thank you so much. Bye bye.